Hello Math 152 students. In this video we are going to take a look at standard deviation, a couple tips and tricks for understanding standard deviation and using StatCrunch. The first thing I want to point your attention to is the videos that are embedded in your e-text. If you click this video icon, each section has a list of videos. If you haven't looked at these already, check them out. Some of them are technology based. You'll see the StatCrunch. You can ignore the TI-8384. Those are for graphing calculators. Some of them are by hand, but others are just discussing the example. These are very helpful if you're struggling with a concept or you just want to hear someone talk about the problem to supplement your reading. So what I want to do is go back to that e-text and discuss why section 3.2 gets tricky. Part of the issue is we're taking concepts and putting formulas to them where the formulas have lots of steps. It makes everything look harder when we look at a gigantic formula. For example, let's skip over range since that's pretty straightforward. Let's say we're talking about standard deviation. If you scroll down, the formula for standard deviation looks a little bit scary. And in fact, when the example in the book goes through it, they give you like all of these steps. We create a table, and it's not very quick. In fact, they even give you two ways to do it by hand using two different formulas. What I want to do is back up and talk about a simple example, try to get a handle of what standard deviation is telling us when the numbers are easy, and then we can go back to a more complicated example. So we're going to deal with a similar context as the example here. These are test values or test scores, but instead of dealing with a larger data set, kind of messier data, we're going to look at 4 individuals who have very nice test scores. Let's say we have scores of 70, 80, 70, and 80. If we wanted to know the average, we could do that really quickly, 75. And the standard deviation is trying to tell us how spread out our data set is, giving us one number to encapsulate that. But we want to work through a series of steps, which is what your formula is telling you to do. The first step in that formula, when you're reading your book, is to find the deviations. The deviations are just saying how far is that first value from your average. How far does that first value deviate from your average? That 70 is 5 points below average. That 80 is 5 points above. So you can calculate the deviation for each test score. And one thing that is always true is that your sum of your deviations is 0. Some of the values are going to be higher, 80, some are going to be lower, like your 70, but in the end, they're all going to balance out to have a sum of 0 because they're centered around your average. So knowing the sum of your deviations is 0 kind of puts us in a not so great place. If this happens for every data set, for example, if I change this to 60, 90, 60, and 90, my deviations are negative 15 and 15, that sum stays 0. If this is happening, that value is not very helpful. In other words, these aren't really what I want. So the next step in your standard deviation calculation is to say, well, we don't really want those negatives. The problem is they cancel each other out. That's problematic. So one way to take care of this mathematically is to square the number. When we square a negative number, it becomes positive, and we don't have this effect of the deviations being negative. So we square those deviations, and the sum of those numbers is never 0, unless we had values that were all the average. So just for a quick comparison, let's say we change this back to 60 and 90. Notice what happened. Those squared deviations skyrocketed, and the sum got really large. So just that number alone tells us that my squared deviations are very sensitive to change. Let's change them back again. So let's go to our next step. And the next step in your standard deviation is to average that value. So this is a sum, and if we divide that by 4, for my 4 data values, I get 25. That number is called the unadjusted variance. And in order to get standard deviation, you take the square root of the variance. So if we take the square root of 25, we get back to 5. So notice if I'm trying to interpret that 5, this is telling me, on average, each of my students scores 5 away from average. Kind of makes sense. If I change this back to the 60 and the 90, then notice my unadjusted standard deviation is 15. On average, each student is 15 away from average. Now, when I start doing messier data, let's say I just change some of these 55, 95, notice when I start having deviations that aren't as symmetric, this unadjusted standard deviation is going to get a little messy. So this value of approximately 17.7 is saying none of these values is exactly 17.7 from 75, but on average, the deviation from our mean is 17.7, which kind of makes sense if you compare back to these values. So a couple of observations here. If you're working with messy data, your standard deviations are going to get messy when you're taking square roots. The other thing we want to observe is our standard deviation is very sensitive to change. If I were to take these back here, and maybe just change one of these values. Let's say one of the students bombed the test, made a 40. That standard deviation jumps up quite a lot. So let's talk about what we mean with the unadjusted, or the unadjusted versus adjusted. Your book also discusses this, and this is the difference between population and sample. What I call the unadjusted is the same thing as the population standard deviation. We're using the Greek letter sigma, and we use that sigma when we are dividing by the number of data points, not n. When we are talking about a sample standard deviation, we will use the letter S, and the only change there is instead of dividing by the number in our sample, or population, we subtract 1. So if I wanted the adjusted variance here, then what I would do is take this number, sum of my square deviations, divide by 3, and then you take the square root of that. I don't want you to worry about Excel. Right? You're not going to be using Excel. You're going to be using StatCrunch. But what I want to point out is the difference. Here, these adjusted values are going to be different. And StatCrunch is going to be able to give you both, which is nice. So let's pop over to StatCrunch. If you were to type these values into a blank StatCrunch page, you would hit Stat, Summary Stats, Column. I'm just going to do variable 1. I'm going to deselect what I don't want here, or at least make sure I have what I want. Make sure you hit Control, and let's do unadjusted variance, unadjusted standard deviation. Oops. And then variance, and standard deviation. We're not going to be using this standard error in Chapter 3. We'll see that pop up later in the course, though. So notice what happened. The unadjusted variance and standard deviation were those numbers that we mentioned. And notice I changed these back a little bit, but let's say I change them back here. I'm getting 5.77 for my adjusted standard deviation, which is exactly what StatCrunch is telling me. So what do I want you to get out of all of this? I want you to understand the concept of what standard deviation is doing. You are taking deviations, squaring them, averaging, and then taking a square root. This gives you a number that you can compare the data values to the average of this data set and make some observations. In practice, what you're going to do is what I just showed you in StatCrunch. Use StatCrunch and calculate whichever one you're being asked for. This is where context is going to come into play. If you know that you have a class of 4 students, then you might be interested in the population standard deviation or the unadjusted. If this is a sample of 4 students out of a class of 30, and you were to calculate a standard deviation, you might be looking at the sample standard deviation and use the adjusted value. This would be S in your textbook, and this one would be your sigma in your textbook.